Welcome to part 3 of this SFD 1001 repair video. Now at the end of last week's video we left it in the state that it was not actually working. The power light came on and the drive light came on and that was it. This week we're going to find out why and hopefully get it working. The SFD is a PET IEEE 488 drive, even though it looks like a 1541. And the interesting thing about this particular drive is that it used to belong to the company where I got my first ever programming job. Now the power light is supposed to go through a self-diagnostics sequence, and the power light will flash red, the drive light will flash red, and then the power light will go green. It didn't do any of that. This is the SFD 1001 that we've been working on. Now there are some things that we can do to test this quite easily if we have one of these, and this of course is a 1541, because inside the 1541 there are a number of components that are common to both this drive and this drive. For example, the 6502, which is that chip and that chip, both machines have, well, this one has two 6502s, this one has one 6502, but also the 6522 VIA is common on both machines. So what we can do is we can take these out, these three chips, and we can test them in the 1541, and we will know whether these are good chips. We can't test the other chips in that way, so that's the 6530, the 6532s, and of course the ROMs, and the static RAM. These are 2116s which are soldered in. We can't test those, but we can test the ones that we can test, so let's do that. First thing I'm going to do, anti-static wrist strap, and then we can just take these chips out. That's one. That's two. The more times you do this, the easier they come out. That's three. Okay, so we can test them in the 1541. Let's set that up. I'd like to thank my sponsor for this video, PCBWay. PCBWay is a high quality manufacturer of printed circuit boards, and they have prices starting from just $5. They make things like this. This is an IEEE 488 interface for a Commodore 64 and 128. Now, assuming that we ever get this SFD working, then this is going to be the ideal thing to use with that drive and have it on our other 8-bit machines. As well as shared projects like this one, you can have PCBWay make up your own PCB designs as standard or advanced or even flexible PCBs. You can have 1 layer, 2 layers or more. In fact, 4 to 6 layer PCBs are now up to 20% cheaper thanks to reduced material costs. So whatever your PCB requirements are, whether you want to build a shared project like this, or whether you have your own PCB that you're prototyping, or whether you even want a production run, then check out PCBWay. Their website is in the link below, www.pcbway.com. Now back to the video. So this is our test setup. I've got the 128 here and the 1541 here. Now I've got a couple of floppy disks. This is the regular C128 diagnostic disk, and we'll use that to read a known disk. And this is just a gash disk that we're going to format and write and prove that we can do those things. So these are the three chips. I've put them into some anti-static foam, and we can test them. Pin 1 is at this end, just remind myself. Okay, so let's do the test with the 1541 in its own chips, or with its own chips. Power. Power. Good startup, green light. It rattles the head a bit. Okay, let it settle down. Stick a write protected disk in it. Hit F3, read a directory. That's good. Take that out. Now this has been previously formatted, so I can hit F3 and read a directory. There we go, 1541 disk 664 blocks free. So we can format that. I can't even type. Ah, we've got a problem with our F key. Repair needed. Right. Let's not worry about that now. It's wobbly as well. Let's call it new disk 1. Are you sure? Yes. Go. It doesn't take a moment because it only writes the directory. So let's new disk 1. Let's just run a little program. Where's the thing on this? Yeah, Shift 0. Ah! No F, so you're going to be called ANS, not fans. Save it. List it, there it is. Nothing in memory. There it is. So there we go, we've read it, we've written it, and we've reread it. So let's switch him off, switch the mains off as well. Now we have got a 6502 and two 6522s. One of those will control the drive and the other one will control the serial bus. Now I don't know which one is which, so what I think we will need to do is put our 6522 in both sockets and perform the tests. And we have two 6502s to replace that one 6502 with. So let's go with the 6502s first. That's the 6502. These are the 6502s. They go the other way around. Right, 6502, and it is the correct way around. There's the notch. Power it on. The light comes on. That is working. It did its clickety click. Do a directory. It is reading. That is a good 6502. We don't really need to do any more testing of that, because either it's going to work or it's not, since doing anything relies on having a good 6502. So that's the first one. We can stick a tick on him. Tick. Pull him out. Take the next one. Remember, we have to turn it the other way around. Oops. Butterfingers. Right, that's in. Double check. There's the notch. Power the drive. Green light comes on. Ah. That is not so good. Drive motor is on and drive motor stays spinning. So that looks like it's a bad 6502. I'm going to put a cross on that. It feels warm, it doesn't feel hot. Let's just try it again in case we hadn't seated it properly. Right, that's in. No, that's the same result. I think that is a bad 6502. Okay, we'll put the original back in. Did that wrong. Okay, that's better. Yeah, that's fine. So again, we just do directory. That's working. So now we can try the 6522, and we've got two positions that we can put it in. the right way. I don't know which of these does what, so we'll try this one first. Six five two two 6522. Directory, it reads the disk. I think if you specify the I parameter, that forces it to do a full write. It's just a guess. But it's interesting, it's stepping across all the tracks, whereas the first time we did it, it just didn't. Just did a quick format. Let's turn that off. I apologise for the fan noise on the first part of this clip. But it is summer and it is hot. Okay. Alright, I obviously did that wrong. You just specify 2 characters. But we live and learn. Right, and let's just do the write test. Yep, that works. So what we'll do is, that seemed to work with the serial bus and it worked with the drive, but because I don't know if there's anything that it didn't test, I'm still going to swap it around into the other chip. There we go. So I'm going to put a tick on this. And we can put him back in the SFD. Let's put these chips back, or at least the 2 good ones. This is the 6522, it goes in here, it's that way around. And this is the good 6502. I did check which 6502 came out of which socket, and this one came out of here, which means the socket, the 6502 that was in this one, is the one that's bad. Now, fortunately, I do have some new ones. These have been tested in exactly the same way that we tested these other 6502s, so they do work. And I think they are new old stock. They have a little label on them that says where I bought them, but this is not an endorsement or anything like that. It just happens to be that's where they came from. So he Oops, did I screw that up? Immediately I screwed that up. Let's scrunch him in the chip scruncher. And have another go. There we go, right way round, right way round. So should we try it? What do you think? Let's give it a go. What could possibly go wrong? I'm sure some of you are coming up with a big list of things like that would answer that. Right, everything is that's ticked. That's new. Let's try it, shall we? Well, nothing will happen if you don't switch the plug on. And that is exactly the same. However, we do know that this works, and this works. That was not pushed down properly. Does that make a difference? Yes! Look at that, it went through its startup sequence, that drive went out and that light went green. And it's all because that ROM chip was not seated properly. Well, how about that? Next thing we're going to do is, I think, plug it into the PET and see if we can actually talk to it. Let's take a quick overview of the architecture of the SFD, because at first glance it looks like it might be a bit complicated, what with having two CPUs and so on. I've scribbled a quick schematic of what's going on. We've got basically two computers. So we have a 6502 and we have a 6502. Now the first 6502, which I'm going to call the bus controller for the sake of argument, is this one. And this is very similar to what you will have seen in a 1541 or a 1571 or a C64 even. And basically it has two ROMs, low and high. That's these. It has some static RAM, which is this and this. That's these. And it has some I/O, which is this and this, and that's these. And there's some clock jiggery pokery that generates the clock for that, and so on. And some buffers also. Here, these are buffers that go between the IEEE 488 bus and the I/O chips. And then the other CPU, which is the interesting one, we're going to call this the disk controller CPU. That's this one. It also has a ROM here, and it has some I/O, which is here and here, and it has some RAM, which is, strangely enough, here and here. And the I/O controls this lot, basically, which is the analog circuit for the disk drive itself, and the motor controls and the head controls and the GCR encoding and decoding and all that good stuff. So that's the basics of it, and in a little bit more detail, these are regular ROM chips, and we can replace those with EEPROMs. I think they're 4K each, so it gives a total of 8K of ROM. And these two are what are called Riot chips. They're 6532, and Riot stands for RAM, I/O and timer. So apart from the fact that they have RAM, they are effectively the same as a 6522. Think of the 6532 as being a 6522 plus some RAM. Now the RAM in these two chips basically forms 0 page for this guy. The other 6502 has its own ROM. That's its operating system, so that's sort of DOS and that's kind of DOS. The 6522 is exactly the same as the one in a 1541, and it controls the motors and heads and so on the drive. The 6530 is on this strange looking daughter board, and the reason for that is that a 6530 is a RRIOT chip, RRIOT, and that stands for ROM, RAM, IO and timer. So it's like we took a 6522, added some RAM to it, and that became a 6532. Now we've added some ROM to it, and that's become a 6530. The ROM inside these it's a mask programmed ROM, and these are specific to the drive mechanism. So if you have a different drive mechanism, then you need a different 6530 with a different ROM in it. And because of that, and because there are so many drive mechanisms and so many variations of this, what Commodore decided to do was split this out and basically ignore the ROM that's in the chip itself and use this EEPROM. So hence this is what this daughter board does, is it provides a little bit of logic that says don't use the ROM inside here, use the EEPROM. And that way, if we change the drive mechanism, we just need to swap the EEPROM, which is easy to do and it's a very common chip, and we don't have to worry about putting in a new 6530, which is going to be hard to find and expensive even in the Commodore days, because they were very, very specific. And doing this means that we can put pretty much any old 6530 in here, because the only difference between them really is in terms of the ROM, and we're not using the ROM, we're using the EEPROM. So yeah, and what this does is this basically controls all the GCR encoding and decoding. So that is basically the architecture of the SFD. Now you will have spotted that the two 6116 SRAMs are actually used by both computers, and this is the only point of contact between the bus computer and the drive computer. And what this does is it forms basically an instruction queue, and the instructions for what the drive needs to do, read a directory, write a file, whatever, comes in from this computer, and it adds an item to the queue in here. This computer reads the queue and says, oh right, I've got to go and read a directory. So it goes and it does its stuff and it sends the results back. And this computer then sees the results come back and it says, okay, right, I've got a directory to send back to the IEEE bus, and off it goes. Now it can do that because the clocks for these two computers are in fact 180 degrees out of phase. And so they never try to access the static RAM chips at the same time. So that one talks, then that one reads, that one talks, and that one reads, and so on. And everybody is happy. And there we have it. I haven't really gone into all the little intermediate logic chips and breaking down of data and all that sort of stuff because I don't entirely understand it myself. And on the later drives, that just gets replaced by a sort of analog big lump of black goo. Okay, and now back to the testing. What we've got here is the mini PET and the SFD. The mini PET is plugged into the TV via the composite lead and is plugged into the SFD via the IEEE 488, an adapter that goes between a regular IEEE cable and the card edge connector, and IEEE cable to the SFD. So let me readjust the camera so that we're pointing at the screen so we can see what's going on. I'll just switch the PET on. There we go. That's as much of the PET as you really need to see, to be honest. Okay, right, here we go. Okay, the mini PET is on. The SFD power is on, and let's switch it on. Now we'll just do query DS $, and that tells us 73 CBM DOS v2.7 00,00,0, and that is excellent because that is exactly right. The 8250 and the SFD all run DOS 2.7. Good. Now we can't read a disk because we don't have any 8250 format floppies, so what I'm going to do is take the disk that we used on the 1541 and see if we can format it. So the header command is exactly the same as it was on the 128. SFD test. Are you sure? Yes. That's a good start. That's a bad start. We heard the drive motor go, we heard it graunch the heads against track 0. I don't think this has a track 0 sensor, so it bangs the heads. Bad disk. Let's see what the actual error was that it came back with. 75 format speed error. 01,00,0. 01 is the track number, so it's the first track it was trying to write, so that would make sense. That could be a problem with the spindle drive board that we recapped. I don't know, it points in that direction. I'll have to have a think about that and we will have a look at it. It certainly was turning because we could hear the motor going, but maybe it was going at the wrong speed. Maybe it wasn't going fast enough, or maybe it was going too fast. I think there might be a little pop to adjust. We can try that. As you can see, the drive is in pieces again. I've taken off the magnet stroke flywheel and unscrewed the circuit board. There is a twiddly knob thing potentiometer on the top side of this board which adjusts the speed. The problem that we've got is that there are two connections to this board from the other side. There's this four-way connector here and this two-way connector here that are soldered on. So we can't just take this board off. And what we've got to do is basically get these wires out and lift the board up very, very gently. Oops. And I don't know if you can see, there is the potentiometer. We need to adjust that, then reassemble it all, see if it's made a difference, and rinse and repeat until hopefully it works. So again, if you can see it, there is a little red mark on the edge and on the barrel, so those line up. That's the position that it's starting from. I guess that was the factory set position, but of course we've changed all the capacitors on here, so that probably means that the speed needs to be recalibrated. So I'm going to just see how far it will turn in either direction. Going that way is quite a long way. Going that way is not very far. So I'm just going to turn it to there. So the red mark on that is pointing basically straight out. I have no idea if that's a good adjustment or a bad adjustment, but that's what we'll do to start with. And now I have to basically put it all back together. And that goes in there. Now I might have to strap this chassis to the ground. I don't know, we'll have to try it. So, switch on the mains. I'm going to hold that so that hopefully this camera can see it, but let us switch it on and see what happens. Okay, the light came on and came off. So I'm going to stick a disc in. Switch the PET on. Okay, let's drive not ready. Okay, that's interesting. This is the test. That's exactly the same. So what I'm going to do is try basically a bunch of different positions of that potentiometer and see if I can get a better result than that. Now the procedure is going to be exactly the same. Undo it all, tweak the part, do it all up again. So come back when it's done. Now even the dumbest of wise monkeys eventually discovered that on the back of this board there is a hole exactly where the potentiometer is on the other side, and inside that hole is a little very tiny screw head. And so with the smallest of screwdriver blades from the iFixit kit, we can actually go in there very carefully and tweak this setting. Unfortunately, what seems to be happening is that no matter where that is set, when we try and issue the format command, are you sure? Yes, this happens. And we can tell the motor is going round, but that's about all that is going on. So, is it the drive motor that is the problem? It seems to be going around and it is approximately the right speed. I'm not sure that the speed variation matters that much. All that's going to happen really is that you'll get an overrun if the end of the track meets the beginning of the track as it writes it. And I don't think that's really in danger of happening. The other possibility is that the heads are damaged and they don't work, or there's something else on this board that is damaged. I'm not sure where to go from here. Either we try and get a new drive or a new board or new heads or something that we can swap out and see if we can discover what is the problem. I'm reasonably confident that the problem is on the drive and not on the main board, because if it was on the main board I think this would probably not go at all. Again, I might be wrong. Thought will need to be given. I've gone over this repair area with a fine-toothed multimeter and all the traces go to where they're supposed to go. All the capacitors are in the right way round. I've double checked that. And the same here, this earthing screw connects to this wire here. And we don't have a strap that goes between here and here. I don't know if that is going to be significant. I can try that. It's probably not going to make a difference, but you never know. Now I've taken the drive out of its casing because I have made a small breakthrough, and unfortunately I did it while the camera wasn't running, so I'm going to have to show you what I did and what I found. Now we need to unplug the drive and turn it over, because what I found is basically underneath. Now I'm going to need to disassemble this entire thing to show you what I found, because basically, let me draw you a little picture. Now we've already looked at what the digital side of the disk drive is like, so now we want to look at basically what the drive itself does. And we have essentially two connectors going from the digital board to the drive. A big 24-pin connector and a smaller 12-pin connector. Now this goes to the spindle motor and the stepper motor and the sensors. And this goes to the top head and the bottom head. So the sensors is what we want to look at on the drive, and the drive LED as well. There are basically two sensors on the drive mechanism. Right, protect. That's the little tab at the on the side, and the index sensor. Now the index sensor, and let me just show you the drive mechanism. We can see those sensors. This is the write protect sensor, and this is the index sensor. Now, both of these have a counterpart on the underside, on the drive board. The write protect sensor is here, and the index sensor is in fact underneath all of this lot. If you remember, we had to, when we disconnected this, we had to disconnect two cables, this 4-way cable here and this 2-way cable here. Now this 2-way cable actually goes to the index sensor, which is underneath the spindle, underneath this board, and underneath another plate that's underneath that. Both of these sensors have basically an LED and a receptor, so the light shines through, the sensor receives the light from the LED, and it either indicates that the write protect tab is closed or open, or the index hole is closed or open. And if we look at a floppy disk, you'll see that there's the index hole there in the tab, and if we spin the disk around, there we go, you'll see the actual hole in the disk itself. Now Commodore disks have traditionally been soft sectored. In fact, they're all soft sectored. And what that means is that the track and sector is actually written into the data itself. So imagine that's a block of data. So it has the track, it has the sector number and the data, and so the disk will know automatically just by reading something off the disk exactly where it is. So it doesn't really need the index hole, and it doesn't normally use the index hole. But on this drive there is one time when the index hole is used, and that is when the disk is formatted. And if that sensor is not working, that is what is generating the 75 format speed error, because it does not see the disk going round, and so therefore it assumes that the disk is not spinning correctly, and that's what's generating the error. And so I discovered that in fact this sensor, this little very tiny ribbon cable that we had to remove, was actually broken. So I had to disassemble this, and I'll show you it very quickly. I've taken this off so many times now. I shall know this for the future, but there is no need to disassemble that or to unsolder that connector if you take out the underlying control board. So free up this wire, and then you'll be able to see exactly what's happened. I had to replace the ribbon cable with you can see it, a couple of wires. And this is the ribbon cable itself, which is broken. I've just left it in there at the moment. So let's move that out of the way. This plate also comes off. Very tiny screws, don't lose them. And then under here is the index sensor. Now, because that was broken, I had to basically put some ordinary wires on there. That fixes the 75 format speed error, and we'll see how far that now gets us. So it's all plugged in. Now let us turn it on. Okay, I've got the mini pet running here. If you want to see the videos where I built this mini pet, then they are linked up in the top corner. Well worth a look. You can build this yourself. It does the whole business. So I have the gash disk. From before, so let's put that in and let us type $DS $. That will just tell us the status of the drive. 73 CBM DOS V 2.7, which is what we want to see. Now the command to format a disk is header. Name of the disk, we'll call it test1. Then we give it a comma and an ID number. FD for floppy disk, why not? Comma D0. You need the D0 on these pets because it could have been D0 or D1. Are you sure? Yes. Now the head's gone back to track 0. As before, it has not immediately failed with the 75 format error, which is good, but it's also not doing anything. I would expect the head to be stepping forwards by now. The disk is spinning.
5 minutes later.
There we go, it's stopped, and it's come up with a bad disk error, which is what we would expect. But if we say $DS $, that will give us a status from the drive. 21 read error 7801. What we have, the 78 is the first outer track on the top surface. So the tracks are organized on the bottom surface with the bottom head, that is track 1 through 77, and then on the top is track 78 through 144. So basically that's telling us that it's got a problem either reading or writing to the top track. And the way it works is, I believe it writes to the bottom track, then it writes to the top track, and that's basically just creating the index or the first track to format. So now I think we are looking at a problem with possibly with the top head. I have got this, which is a disk that has been formatted on an 8250, and so I can put it in the drive and hopefully we might be able to read it. This will actually tell us whether we can read disks with it or whether the entire thing is faulty. So let's see if we can actually read a disk. 8250 and 4132 blocks free. There is a 1 block program on here called test, but at least it can read a directory off track whatever it is in the middle. So let's load this test program. And I know what it is. It's a very simple program that says this is a test. Okay. So let's change the program and see if we can save it. Check what it was called. So that was called test. Let's save this. Test 2 seems to have done it, and there it is. Let's just check that it actually saved. So clear it out of memory, prove that it's gone, and there it is. So it is loading and saving, so it can read and it can write. Now, the way that it organizes itself, it always fills up the bottom track, or rather the bottom surface of the disk first. So this only proves that we can load, or we can use the bottom of the disk. So it only proves the bottom head is working. It doesn't prove that the top head is working or not working. But we have advanced. We now have what we know is at least a partially working drive. We can't format disks, but we can read existing disks and write to existing disks. That's a positive step. So I added some heat sinks to the main chips on this thing because they were running rather warm. The 6532s, the 6502, 6522, 6530. This one I haven't put a heatsink on because I ran out of heat sinks. But now when I switch it on, this happens. Okay, sometimes that will give an error, sometimes it doesn't. But let's look at the screen. When you know it's working. As soon as you turn the camera on, it starts working. But as soon as I type directory, you see we get a red light. And then 66 illegal track or sector. Now what on earth does that mean? It's not even attempting to move the heads to read the directory. So does this mean that one or more of the chips has blown? Does this mean what? I don't know. Maybe the sockets need replacing? Speculation at this point. Adding the heat sinks, I didn't actually remove the chips. I didn't actually touch the chips apart from, well, sticking the heat sinks on the top. So it shouldn't have changed anything. Switch it off and switch it on. Now it's giving the error that I used to see. And you see it's giving a sequence of 4 flashes. The problem with that is I go and look that up on the list of what the startup error flashes mean, and it says 4 flashes unallocated. I don't know. It seems like 1 step forward and 2 steps backwards. We fixed the 75 format speed error. We found that that was most definitely a broken connection on the index sensor, and that led us to a 21 read error or a 20 read error depending on when I did the test. And I didn't get very far in investigating that because I had a feel of the chips on the main circuit board and I figured that they were running pretty warm, if not quite hot. And so I decided to put some heat sinks on them. And in the process of putting heat sinks on them, the board stopped working, basically. Now, whether that was because the chips were so hot that they decided to fail, I don't know. Maybe it's a contact problem with the horrible single leaf sockets. Maybe one or more of the chips has died. Maybe the quality of the contact between the ICs and the legs is not very good. So I think, in lieu of very much else in terms of ideas, I think it's time to take those sockets off and replace the sockets with known good quality double leaf sockets. So I think that's what I'm going to do. I think the first thing to do is get all these socketed ICs off the board, and then we can start desoldering. So right, the sockets are all out. They just need a little bit of cleaning up. Okay, I've got sockets. They're not turn pin sockets, unfortunately, but they're what I've got. They were actually for another project, but you know, the needs of the SFD are greater than the needs of the other project. And I shall install those and then come back to you. Okay, that's done, so let's now put the chips back in and put it all back together. There we go. Okay, the drive is back together and plugged in, so let's switch it on and see what happens. 3, 2, 1. Oh, that's good. Perfect startup. Let's turn it off and turn it on again, see if it does the same thing. Ah, 4 flashes again. Okay, see, now it's working again. That is weird. Let's put in our known working floppy, the 8250 formatted one. 73 CBM DOS v2.7, that's good. Let's see if we can get a directory off it. And no. 66 illegal track or sector 00,00,0. So, decoding Commodore error messages. Track, sector, drive. Drive is always going to be 0 because this is a single drive. Track is 0, sector is 0. Now, it should be attempting to read the directory. It didn't even move. So I wonder, because 0 is actually an illegal track number, because the first track is track 1. And so if it's trying to read track 0, then that is correct. It is an illegal track or sector. We are still 1 step forward and 2 steps backwards. I think we have to call it with this project at this point. There is a fault on the main board that I'm not sure that I know what it is. I suspect it's going to be the 6530 because that's the one chip that we can't replace. It could also be somewhere in this 7.4 logic, and that's before we even get back to where we were sort of halfway through this video, which was the read error on the drive mechanism. Now, maybe that read error is actually also somewhere on this logic board. Maybe that read error is a fault of the 7.4 logic. I don't know. We're not going to sort it today. We're not going to sort it quickly. I can't get a replacement 6530. They are rarer than unicorn's teeth. I might be able to make an adapter board that will put in a 6532. I suspect I'm going to have to delve deeper into the discrete logic areas of this board, and I need to learn what's going on really. So for now at least, I think that's it. I'd love to get back to this because, as I've said before, this is an SFD that holds some sort of significance to my past, and I'd really like to get it working. Meanwhile, please click the like button and click the subscribe button and do all that wonderful thing, and there is a video somewhere on the screen that you'll probably like to watch next. See ya!